I have with me the museum's Corinne Tate to talk about heart attacks and a new technology that may be used to help heal the heart after it's been damaged. Hi, Corinne.
Hi, Susan. Thanks for having me.
Thanks for being here. So, first, we're talking about heart attacks and a way to fix hearts after the heart attack. What happens to a heart when an attack happens? What does it mean to have a heart attack?
Well, when you have a heart attack, it means that blood supply to the heart has been compromised in some way, either from the narrowing of an artery or a plaque blocking an artery, and an area of the heart becomes starved for oxygen. And what happens is those cells, nerve cells and muscle cells in the heart, they actually die because they don't get enough oxygen. And the problem is that now you have a part of the heart with dead cells, and that weakens the heart and it disrupts its ability to beat with a strong and regular rhythm. And even after a heart attack is treated and the heart is functioning normally except for this dead area, the heart is left in a weakened state. And it really puts patients at risk for having repeat heart attacks.
Can a person's heart regenerate the muscle and nerve cells, or do they stay dead forever, pretty much?
They're basically lost forever after they die. Those cells are not able to regenerate on their own, which is one reason that a lot of researchers working in this area are trying to find ways to regenerate those heart cells and help the heart heal itself.
And I believe that's where this particular research comes in, a new way to help the heart heal itself?
Yes. This particular treatment involves a small patch, a little bit smaller than the size of a penny, and that patch is made of polymer and a bunch of carbon nanofibers, these tiny, tiny fibers made of carbon. And this patch acts as a tissue scaffold that in tests it's been shown that heart cells are able to grow very, very well on this tissue scaffold, and the tissue is able to regenerate using this patch.
This seems almost like an obvious idea, to be able to give the heart something to build upon, to help basically, patch up the heart, which is what they're saying. So how did they come up with this particular idea?
Well, the researchers at Brown University, these are bioengineers, and Tom Webster in particular is the professor heading this up. They have this hypothesis that cells are able to grow a lot better when there's some kind of nanostructure to the surface that they're growing on. And in all the tests that they've done, they've realized that cells are able to colonize and grow on areas that have nanoscale features, possibly because cells themselves have nanoscale features, so they're able to grow better on these types of surfaces. And they came up with the idea of using carbon nanofibers on this patch, because they've noticed that the more fibers that they put on the patch, the better the cells grew. So much better than their control, which was just the polymer. They had 3, 4, 5, 6 times as many cells growing on the patch once they added more and more carbon nanofibers.
Are the carbon nanofibers in any sort of pattern, or are they kind of just as many of them kind of clumped all together as possible?
That's actually going to be a big focus of their next steps or their future research, is patterning the carbon nanofibers in the best way to optimize cell growth. And they're still trying to figure out what that is. But another big benefit to using these carbon nanofibers isn't just their nanostructure, which helps the cells physically grow, but carbon nanofibers are also electrically conductive, which is really important for the heart because it's electrical signals that travel between the cells on the heart that get them to contract and expand in a regular pattern. So the fact that the patch itself is electrically conductive, what it does is it helps maintain that electrical signal and keeps the heart beating really well.
Now, how safe is this particular patch being in our bodies, on our heart? Does it eventually degrade? Would we want it to degrade? What does it look like after the heart has regenerated itself?
That's a good question, and that again is an area of research. On the one hand, it's beneficial that these carbon nanofibers, they're biocompatible, so they don't really interfere with the cells, and the cells are able to attach to these. The carbon nanofibers don't biodegrade. In one sense, that's helpful to really get the tissue going well as a tissue scaffold, but in the long term, it is a concern. Most times we want tissue scaffolds to be biodegradable in the long term, and these are not. So there is going to need to be a lot of safety studies to see what eventually happens to these carbon nanofibers long term in the body.
You mentioned safety studies. What kind of studies have been done? Has this been tested in humans or just on, I'm guessing, mice or rats?
Actually, they haven't even gotten to animal studies. These were just done in petri dishes with cells, basically showing that these cells can grow really well on this tissue scaffold. The next step is to do it in animals, and then hopefully that would clear the way for human clinical trials. So it's still very, very early in its research, but what makes this so promising is that unlike other possible treatments that are being tested right now, this patch has been shown to regrow all three types of heart cells that can be damaged. The nerve cells that carry the signal, the muscle cells that beat, and also even the endothelial cells that line the vessels of the heart. So the fact that it's able to regenerate all three types of cells really is creating a tissue that's much more similar to our normal heart tissue that we find inside the heart.
So if and when it does reach humans, how exactly would this treatment work while they're in the hospital after they just suffered a heart attack? Would they immediately, I don't know, does this require open heart surgery to go in and put a patch on the heart and then they wait for it to grow? What does the process look like?
Well, what's interesting is first you would do some imaging to see just what area of the heart was damaged and the shape and size of that area. And then you could customize the patch, basically cut it to match the right size. And the idea is because this is such a small, flexible, tiny patch, it could be rolled up and then inserted with a catheter and placed in the right place on the heart over the damaged area and get cells to regenerate right in that damaged area in the shape of the damaged area.
And it's also, very minimally invasive because you're just using a catheter. You don't have to actually cut open the person to stick the patch in.
Exactly.
And also I'm wondering about what kind of people would be able to get this patch because it doesn't prevent a first heart attack. It only really helps after you've had the heart attack, but to help heal the heart after the first heart attack.
Exactly, and that's a surprisingly big problem. Nearly 800,000 people every year experience new heart attacks that are caused by weaknesses in their heart from previous heart attacks. And as many as 30% of people who have a heart attack will experience a second one within 6 years. So it's really important to focus on how do we heal the heart after damage, because those people are so susceptible to having additional heart attacks.
So even though this technology is still many years away, it does seem to hold a lot of promise. It makes sense being able to heal the heart by giving those cells a place to grow. And the fact, as you said, that all the different types of heart cells can grow because of this patch definitely sounds very useful. So thank you, Corinne, for telling us about this heart patch technology.
My pleasure. Thanks for having me, Susan.
That's it for this week's show, but be sure to come back next time for more of the latest in science and technology. This podcast is a production of Current Science and Technology at the Museum of Science in Boston, part of the Boston community for over 175 years. For more information, visit our website at www.mos.org/CST or email us at podcast@mos.org. Thanks for listening.